Hello everyone, welcome to the SEP Measurement and Verification Case Study webinar. Thank you for joining today. We're going to go over Detroit Diesel's SEP experience over the next 40 minutes or so, and then we're going to end with a 20-minute Q&A session. Just a reminder, everyone in attendance is muted, but if you have any questions, you can type them into the question bar within the GoToMeeting bar on the right. And we will address as many as we can at the end of the webinar. So today we'll have Paul Shine from the U.S. Department of Energy Advanced Manufacturing Office. We'll have Carlo Cortiglione and Chris Long from Detroit Diesel tell their experience, and we'll also have Randy Green from the Georgia Institute of Technology to share some information on SEP as well. So without any further ado, I'm going to hand it over to Paul Shine of the Department of Energy.
Thanks, Yannick. So this is the fourth in a series of webinars we've held on SEP. And there's a number of purposes of this webinar. One, to communicate the business value of SEP. Second, to share the learnings from the SEP pilots from real end users, especially on measurement verification, since that's what SEP focuses on beyond ISO 50001. Demonstrate the rigor and robustness of SEP verification. Then develop some follow-on case studies, and then hear from the SEP community, you folks, at the end of the call about your M&E experiences. Next slide, please. So many of you might be familiar with the ISO 50001 Energy Management System structure, but I thought I'd go over it real quick. This standard is now 5 years old. It is considered the world's best practice on how to manage energy in your facility or organization. And it follows the Plan, Do, Check, Act continuous improvement structure that other ISO management systems follow. It has a particular emphasis on energy performance improvement. And as such, there's a very rigorous energy planning and review process within ISO 50001. Next, please. Okay, so to compare ISO 50001 to SEP, as I said, it's the internationally recognized best practice. It requires a very robust energy data and metric regimen to look at all the energy going into your plant, and as well as focusing on the significant energy uses in your plant. It has a lot of value in that it is a world standard, so it has relevance to, for example, a global corporation that has facilities in many countries. What SEP does is build upon ISO 50001 with a specific energy performance improvement target and criteria that the companies have to meet. Right now it's about 5% over 3 years as a minimum you have to improve. That's going to change slightly moving forward. It is a national program. The DOE administers the program. It accommodates a diverse type of facility in industrial sector, commercial sector, type of program you have, maturity of your program. And it gives transparency over and above 50001 through the rigorous third-party verification that we're hoping that the market will reward in an increasing way. Next, please. So these are the sites and companies, companies that have at least one or more facility that have been SEP certified. Next, please. And today we're going to focus on Detroit, or Detroit Diesel, based in Detroit. And we're going to have two speakers from Detroit Diesel speak today. But first, I'd like to introduce Randy Green from Georgia Tech, who's going to give a short overview of the SEP measurement verification approach And so I'm going to hand it over to Randy right now.
Yes, thank you, Paul. We would like to do a brief review of the SEP approach to measurement and verification of the facility's energy performance. So in SEP, energy performance is really evaluated using two methods or two techniques: a top-down whole facility energy performance indicator that's labeled the SENPI, and then there's a bottom-up sanity check, with check being the key word there. But it's just a list of projects that validate or confirm the top-down approach. SEP utilizes a robust statistical approach for the top-down measurement, of energy performance. It's very similar to the method C of the IP MVP that some of you might be familiar with. But it takes a whole facility approach by developing a linear regression model for the energy consumption at the site. In the slide, you'll notice a typical model for natural gas consumption with the relevant variable of production, and the equation for natural gas consumption is in the upper right-hand corner of that graph. The relevant variables account for, our energy consumption, and may include things like weather, other input characteristics like moisture, and those will vary with the industry. In commercial buildings, look at occupancy and other types of relevant variables. So the SENPI or the SEP performance indicator, excuse me, is a ratio of the total actual energy consumed by the organization and compared to the total energy that the organization would be expected to consume if they had not implemented any of their energy improvement saving projects. So we get a ratio of performance as it is actually measured, and we compare that with what has been modeled, which represents the energy performance as it would have been had no improvements been made. And you see the formula there. In the end, the savings or the improvement is expressed as a percentage, and there is a prescribed methodology for the baseline and performance period. The bottom-up sanity check is just a validation of the top-down. It's a much less robust process or procedure. It's a list of projects with their calculations of estimated savings. It does not have the same rigor as we mentioned, but it is reflective of all the activities that the organization has put in place to improve their energy performance, not just the capital projects, but the other types of activities, operational control, behavior change, and maintenance improvements for their energy systems. The two of these validate each other and give us what has turned out to be a very qualified demonstration of measured energy performance. So Paul, I will turn it back over to you.
Thank you, Randy. Actually, I'm going to introduce Carlo. And I want to briefly, we wanted to play this video, which is a really great video. It's very short. It's 3 minutes. And we had technical challenges in you being able to see it and hear it over this webinar. So we're just making you aware of it. We're going to send out an email after this webinar, and we'll have the link to the video. But I really would encourage you to watch it. It's, like I said, very short, 3 minutes, and it really gets to the value of doing the SEP process, where by the Detroit Diesel team going through the verification process and getting the numbers, they determined that they had saved $37 million over a 10-year period. So with that, I'm going to hand it over to Carlo, and he's going to tell the Detroit Diesel story.
Thank you, Paul, for giving us this possibility to share this. So what we see here is the energy policy which we actually created and implemented just for the ISO 50001 and also for the SEP later on. This energy policy was created and adapted together with our sister plants in Germany. So it is a similar energy policy as we use in Germany, and it's just translated in English. So next, please. In this energy policy, we can see our corporate goal, which is to save 2% annually up to the year 2020. Baseline is the year 2010. So this means 20% by 2020. This is the main goal, the main corporate goal, actually, which is tracked also overseas. Next slide, please. So all our locations worldwide are ISO 14001 certified. And a total of 22 locations in Germany already are 50001 certified. They started this certification process for 50001, let's say, since 2010, 2011. And by 2014, all the 22 locations were certified by a third party. And from 2014, though, we started to implement the ISO 50001 also outside of Germany. And the first facility who's ISO 50001 certified outside of Germany is Detroit Diesel. Starting in 2014 and repeating the certification in 2015, plus including the SEP certification. It was a pretty seamless thing because we could use a very robust existing ISO 14001 environmental management, which existed here at Detroit Diesel already since 15 or 14 years already. So we had many processes already in place we could use for the 50001. So overall, you can see it shows more than 98% is certified in 40,000 worldwide. It's probably very, very, very close to 100%. Next slide, please. Facility background here at Detroit Diesel. Let's go over the project summary. So what we produce here is mainly diesel engines, medium duty and heavy duty for trucks, also axles, transmissions, and many other components like gear sets. The facility is located in Detroit and actually partially also in Redford, which is a suburb of Detroit. Operations mainly are machining, assembly, and a lot of tests. We have a research department and actually test department. Around 2,800 employees, and we work 24/7, 3 shifts, 7 days per week. I mean, yeah, right now there's an economical impact, but we usually run 24/7. SEP certification level is platinum. We achieved 32.5%, which is pretty good, and I think we are second in the United States. We are very proud of that. And the used energy management system is the ISO 50001. Here on the picture, you can see the assembly line where we have our medium-duty engine actually produced. Next slide, please. So that's the overview of the facility. It's a 3.2 million square feet facility. It's a pretty big facility. You can see the boundaries, the entire campus over there. So we actually have some place also to expand the facility in the future if we get the opportunity for that. We are the second largest Daimler facility in North America. And I say Daimler because we have a very big car facility in the Carolinas, but it's the biggest truck facility we have in North America. The scope includes research and development. As I said, we have a lot of testing over there and a lot of diesel consumption. We have some machining areas, assembly areas, especially for engines, axles, and automatic transmissions for trucks, and the engine test in production. So we have a test in research and development, which is a durability test, and they run almost 24/7 and sometimes for a whole year. There's a huge diesel consumption over there, and we also have production engine tests. So we test there for 10 to 12, 15 minutes. Each engine is tested before it leaves the facility. Next slide, please. Let's look at the energy profile. As I mentioned our superior energy user is the engineering, the E4 lab, the research and development department, but also the boiler room. We use natural gas for the boilers, and actually almost 90% of our natural gas, or even more, goes just for heating. We almost don't use any natural gas for our production. As I mentioned, the 50,001 and the SEP certificate, the platinum certificate with 32.5% of improvement, was a big deal for us here on the facility. It gave us a huge stage, actually, also to the top management. We are looking at the baseline period from April 2004 to March 2005, looking at the model period, April 2012 to March 2013, and reporting period is April 2014 to March 2015. As I mentioned, we got certified November 2015. The certification body was DECRA, and we also used an internal consulting, PHI consulting company to support us with that. They are very experienced with the ISO 50001 and also with the SEP. DECRA was the third party conducting the 50,001 and also the SEP verification. You can see the energy usage breakdown, which shows that we have 63% electricity usage. That's actually our probably priority, our biggest utility. Then the natural gas, which is 21%, as I mentioned, just for heating, and then 16% in diesel. And as I mentioned, diesel is used in production, which is the 27%, like 10 to 15% testing in production, each engine, and 73% for our durability test, which is actually a lot. You can see a picture of one of our durability tests right there. Next slide, please. Yeah, Daimler has an extensive, as I mentioned, energy management expertise because all the German facilities are certified already, and now since 5 years they could gain a lot of experience. I was actually asked and sent over to Detroit Diesel to support with the ISO 50001 certificate. I was before responsible for the facility in Gaggenau. This is in South Germany, a facility which is almost the same size of Detroit Diesel, where I implemented the ISO 50001. We don't have the opportunity to actually add the SEP certificate in Germany. I think this is very valuable because it gives you such a great stage, and it's supported by the Department of Energy, and this is very valuable to us and very important. Actually, to assist me, we used, as mentioned, the PHI Environmental Consulting, which is a very experienced consultant in this area, and for many years already in the ISO 14001, and probably since 4 or 5 years now in the 50,001, and also with the SEP section, very experienced. We merged in 2000, at the end of 2015, the ISO 50,000 with the existing ISO 14001 environmental management. So we have one team which is actually energy and environmental management together, and we try to use synergies here and to support the ISO standard, which is currently like more important. So I support my colleague who works more in the ISO 14001 when we get also closer to project, and the other way. The implementation was very similar to the 14001 because there's the Plan, Do, Check, Act, which is almost the same as in the 14001. You have to identify roles and responsibilities. You conduct gap analysis with the SEUs, internal audits, what we do, and we just had last week one. And you need to identify what you do next. and what you need to do to meet the ISO 50001. So this is pretty similar to the ISO 14001. We used a lot of best practices from Germany and exchanged information also with Germany, but I would now say that we are here in a status that we give best practices back to Germany. I think the improvement was so good and so big that we did a great job here, the whole facility, and we are able to show to our colleagues in Germany that they can even learn from us right now. So as mentioned, the ISO 50001 was actually an enhancement of the ISO 14001. Next slide, please. Here I would like to hand over to Chris Long, who's responsible for our ENPIs.
Thank you, Carlo. One of the most important things that SAP does provide you is with the ENPI tool. What the tool does is actually allow you to quantitatively show your energy usage and how much you saved. So what this chart is pretty much telling us is what has happened throughout the facility. This is an old facility that's been here since 31. And in 04, which is our baseline year, pretty much after the transfer from, before it was originally a GM site and then got sold to Penske, and then Penske sold it to Daimler. So a decision was made that are we going to keep the doors open or not? So Daimler wanted to reinvest in Detroit and felt that was a good placement for it. So we had something in our baseline year called the Redford Renaissance. So you see our production extremely low, which is the dotted purple line in 2004. And then you see it go up and down, just like the economy with everything else. But the most important thing is that you start to see our energy go further and further and further down, little by little, but we eventually get there. We have increased our production volume by 93%. Next slide. So with the ENPI tool model, that there's several variables that have to look through: production hours, heating and cooling days. And when it comes to electricity, electricity is one of our major energy users, and production hours and cooling days, we use the AC units for those. Natural gas, like Carlos said earlier before, a lot of it is heating for the area. And diesel is based on production hours. How many, every engine that goes through this facility is hot tested, so it's anywhere from 7 to 8 minutes. And then we have our testing durability stands that go 24 hours a day. Through the model, we use a chaining method. Our model year was 2012 to 2013. And all statistical tests were completed and calculate the savings, which we were able to go to our top management in the facility and tell them how much we saved. Next slide. So this is a snapshot of the model of how we did. You first see a large, once we started investing into the facility, doing repairs, investing into the facility, you see a real quick jump in energy efficiency. Then, as we all know, the economy kind of hit a stall point and tanked a little bit, but it did eventually go up. This is, when you talk about manufacturing is production hours, so that greatly influences the actual model. So it's, sometimes you have your good years, sometimes you have your bad years. However, you start seeing the energy improvement. What you invest during the bad years, you get back during the good years. So you see that efficiency slowly creep up as we continue to go through. You invest for the future when you're talking energy management. Next slide. So this is one of the things that we really wanted to point out once we actually implemented, ISO 50001, and then you have SAP into it. You see the increase. Between 2014 and 2015, we increased our energy efficiency by 7.28%, almost a 40% energy improvement. So that kind of shows how robust the system is, and it brings a lot of attention to the facility. Next slide. So when it comes to any facility, dollars and cents at the end of the day are everything. With the EMPI tool, we were actually able to calculate how much energy we actually have saved. So through the tool, you can see that we show the MMBTU that we saved, and then we turn around and through invoices, we figured out how much we paid per MMBTU. We calculated it up, so we have over $12 million savings in electricity. You have $7 million for natural gas and about $17 million for diesel. You add it all up, you get $37 million. This is an extremely important number to our management here. That shows we are producing engines here for absolute less, which help the bottom line, which are able to fund more and more projects. The whole part of manufacturing is to be as lean as possible and be able to get going. So SAP allowed us to show our top management this number. Now you just made it extremely real. And that's an important part when you're talking energy management. To get support, top management is extremely important. And when you tell them, hey, I just cut you a check for $27 million or $37 million, that gets you a lot in the facility. Next slide. So one of the good parts and that we quite enjoy is great that you save this energy, and you have the model, but really, how did you get there? What did you do? And this list is pretty much Daimler did heavily invest into the site. So we went through and systematically replaced a bunch of the roofing. We went from a R2 roof to an R24 roof. We also replaced windows for energy efficiency. We also went through an energy combustion efficiency program with our boilers, since the boilers are a significant energy user within our site. So we're using our natural gas to the most efficient possible. We also did a steam reduction program. We are almost to the point where we can shut down all the steam in the facility during the summer. Steam is an extremely inefficient way of heating up things around here, but so we have systematically tackled that. Another kind of expensive energy user is compressed air leaks. A lot of people just take it for granted, oh, it's just air, but the compressed airs can be extremely expensive. So we actually implemented a leak detection program where we have our guys go through and find major leaks and repair. And we also replaced one of our compressors. We have now, as Carlos stated, this is a 3.2 million square foot facility, and we use one air compressor for the entire facility. So we've made monumental increases in efficiency with that. We also went through and repaired and upgraded all the HVAC systems and controls. We also replaced the chiller. Our facility has gone through a relamping program where we are replacing all the high pressure sodium lights that were in the facility to LED lights. We have maybe about 60% of the facility with LED lights. Our plant manager loves them. Our union loves them. Everything is now visible and upgrades every other management system around. So our plant manager has dedicated himself and pretty much said by 2020 that the entire place will be LED lights. We also developed a secure building envelope program where we have our security several times a day go through the facility and make sure that all the external windows and door and garage doors are actually closed. This is an important part because if you're paying to air condition the facility and then you're opening up the door, it's just like your mom always said, close the door, I'm not trying to air condition the world. We also went through and looked at other things, just not the facility. How do we do things? Our engine paint, we replaced our engine paint to a waterborne paint. The waterborne paint actually allowed us to have a lower cure temperature, so we're able to reduce the temperature of the ovens, which helped out a significant amount. We also have put in a variable speed drive program. Every pump and motor that we go ahead and replace now has a variable speed pump instead of just a regular pump, so we're not uselessly wasting energy. Like Carlos said before, our R&D facility here uses a ton of diesel fuel. And before they were just running for one test, the engine. We said, well, how can we tackle this? We need to research, we need to run engines. So we were able to all come up with a thing of actually a layering system where they're testing several parameters at one time. So that cut down diesel consumption by a great amount. We also went through some changes in the facility. Old standard used to be the Series 60 engines, which has an outdated engine, and we have changed over to the 8-step engine. So all the old machinery that were originally built for that, we were now able to get energy efficiency machines in here. Every machine that comes into this facility has a check mark of, is it the most energy efficient machine on the market, and how can we reclaim some of the energy that we use in that. Next slide. So here's pretty much where we were talking about before. We were doing kind of energy efficiency, but kind of saying a maintain. And then right when we decided pretty much, hey, we're going to follow our sister plants and do 50,001, you start to see the awareness creep up, and people are like, hey, energy is something to pay attention to. And then right when we said, hey, we're going to do SAP and commit to that, and we were able to show how much we are saving, our top management really pushed it and made energy a part of everyday operations. So as you see with SAP, it invigorated the entire plant to have a better energy performance. Next slide. I'm going to go ahead and turn it back over to Carlo, and he will talk about the next slide.
Thank you, Chris. As we now mentioned a few times already, management engagement is very important, and I would almost say that's everything, because when we started the program ISO 50001, we really worked on getting all the management engaged here. You can see on the picture on the bottom left, this is our management attending our monthly meeting and sharing, actually, where we can share our information. And it's not anymore like they have to attend, it's they request that we give them an update right now, because they really like to see how we save money and how we get more efficient. So it's very important also for the time requirement. I mean, you need manpower, you need time and expertise, and if you have management engaged, you get all that. And if you get the stage like we got with the ISO 50001 and also with the SEP, it helps. As Chris mentioned, $37 million in savings helps you to get a lot of manpower and expertise. It could still be more, but we are very happy with what we got now. Even with the budget, it helps a lot. And if you look at the competing interests, like cost spendings versus energy efficiency, I think we have like great specs in the corporation in where we make sure that all the new engines which come in or machines which comes in production areas are very energy efficient. So we prefer to spend maybe a little more, but to have an energy efficient production now. And there is a cultural change here on this facility. You can tell there's a difference. Sometimes you can see if you go by the cafeteria around 4 or 5 p.m., the lights are turned off. We didn't have that before. So it looks like people, they change, they have a mind change now and they turn off the lights. It's a little step, but it's great to see that people adapted. So we use the green corner, the picture in the middle, what you see, as our communication center. That's where we conduct the monthly meeting. That's where we have all the energy policies, environmental and energy. On the left side, the green side is the environmental side. On the right side is the energy side. We combine that. We have some of the awards we won over there. We are very proud about that. We won awards in the Daimler Corporation, also here in Michigan with the Free Press. The SEP is a big deal, and with the EPA, and also the environmental leadership, which is kind of a headwater award in Germany, Stuttgart, what we won last year, made us very proud. So we really have a changing plant culture here in place. Next slide, please. Cost-benefit analysis. So platinum, ISO 50001, 32.5%. We over 10 years. That's the mature pathway. Actual energy cost savings is $815,000. We save currently more than $3.7 million, but this is including our new contract negotiation. $815,000 is the plain savings due to the ISO 50001, including the SEP. The cost to implement that is around $130,000, and I mean, yeah, as you can calculate with yourself, it's a 2-month payback period. That's nothing. I mean, this shows that you really, really, really have to go with that. You should implement it. It's worth. And what our plant manager says, it's painless. So on the right side, you see the graphs. It's actually the same information again. Audit preparation around it's $13,000, and ENMS enhancement $53,000, and so on. Next slide, please. As I mentioned, we have an increased awareness in energy consumption, and from the top management, a lot of engagement and stage, and SEP provided a pathway to set even new energy goals, better energy goals, and gave us also the chance to attack projects we never thought we would be able to do that because we would never get the funding for it. Now, and you will see it on the YouTube video, what Paul mentioned right before, the plant manager will talk about what we achieved there, and you can see that he's actually pretty enthusiastic about it and he likes it. So whenever we go there, he kind of thinks, oh, you guys are heroes because you're not expensive, but you're saving a lot of money. That's all what he thinks, but we also have the environment, right? So just for this reason, it's a big deal. And I would immediately go again with SEP if I would be asked about it. As mentioned, our manufacturing engineering is always part of our new equipment procurement decisions. So, and everybody who plans new machines and who plans like new production lines has to use the specs and the standards. And you are always asked on what is the energy impact, what is the environmental impact. So you make sure before you start production that you have the energy efficiency machining on place. Even the Daimler plant managers in Germany, I had the chance to go back last year and talk to some of them, and they were like, what did you guys do there? How did you achieve that? They couldn't believe that Detroit Diesel, a facility in America where apparently energy is actually cheap and it is hard to get a good payback time, and usually industries, they give you budget just if you achieve a 2-year payback time. So they were like, how did you do that? And I think it is a cultural change. I think you can feel it here in the United States. They put the SEP program on top of the ISO 50001, and they push that a lot. I think right now, here in the United States, we are at the level where we can show even our sister facilities in Germany how to do things. Next slide, please. As mentioned, top management is everything. It helps you with your projects to be successful. And when Paul was here, he probably can confirm it that, yeah, Jeff Allen, the plant manager, he loved that. He took the time, he spent a day with us, almost also with Paul, so you can see they are very dedicated. They definitely value the public recognition, and yeah, right, they of course love to spend some time to create the video and to support the system. They are actually asking, hey, what's the next step? What can you do next? What can we achieve? Yeah, we're struggling a little bit because we got so much recognition and so many awards that we right now don't know how to go on and how to show off anymore. But okay, that's actually a good thing. It's very simple. Energy savings is saving money. That's all about management cares. The next step actually is, so now we are here at Detroit Diesel. We have many facilities in North America, Daimler facilities, not Daimler trucks, also Daimler cars, Daimler vans, and buses. So the next goal is to join the Better Plans program and expand the energy management to other facilities. We would like to start with 9 major other Daimler facilities plants, which are most of them in the Carolinas and also in Oregon, where our headquarters is in Portland. That's the next goal. I mean, if we if we are able to use the best practice, shared service, and all the processes we used here, and just copy-paste it to other facilities, I think that's probably better than the next award we can achieve. That's a huge savings. We are looking at millions of savings there, huge opportunity, and I hope we will get a lot of support from the Department of Energy using the Better Plans program. Thank you. Next slide, please.
So thank you, Carlo. And you will get support once you join the Better Plans program. All right. Good job, guys. Okay, we're going to take some questions now. And there's a few questions listed in the question box. If you have questions, please put them in, and I'm going to read them. Okay. The first question is, does R&D at the site have the same reporting chain as the plant? For example, do they report to the same management? If not, were there issues gaining the buy-in needed from R&D and their associated management? What strategies were used to overcome any silo issues?
Yeah, R&D has a different reporting structure, and they have also different management they report to. They actually report to the top management directly in Germany, and the rest of the facility reports to the top management here in Detroit. So we created like an interdisciplinary team, which included all the directors, also the directors, all the directors on site, including the directors from R&D, and we invited them to an event where we explained what our goal is and what we would like to achieve, and asked them if they would commit to our goals. And R&D asked the management in Germany, and since they saw that there are huge savings and a lot of money actually involved and huge possibilities, they committed to it, and they are very supportive. They are also part of our monthly plant management meeting, and they are tracked with the same KPIs as the facilities. We track the whole facility with one main KPI, and then we have KPIs for each director himself. So yeah, I think it's important to show them what the possibilities are, what the potential is, and it is very important to ask them, to involve them. Just go there and tell them, hey, we can save you some money. Would you like to commit to this goal? And overall, I think the plant manager did a good job there in bringing all the directors together, R&D or production or assembly, doesn't matter, and that's how we approached it.
Okay, very good. Okay, next question. How did your utility support your pursuit?
Like the utility provider?
Yeah, I guess it would be Detroit Edison in your case.
Yeah, I actually did wonder. They have rebate programs. So if you use renewable energy sources, or if you relamp your light fixtures all and use LED in future, they have rebate programs. Also, if you installed, as Chris mentioned, VFDs, like variable frequency drives, they have rebate programs. And this was the chance to switch from regular lighting to LED and get a $60,000 check from DTE and hand it out to the plant manager. So we told him, oh, we relamped that area, it's all LED, and you know what? Here we got your $60,000 check for it. He liked that, so DTE supported us a lot. And we actually got also rewarded and awarded by DTE for energy efficiency in large businesses. Also, you'll have to see that Michigan, where we are here, it's not deregulated. So DTE is our supplier and will be our supplier. And they did huge efforts to adapt the rates. So we not just saved energy, we also saved money at getting the rates adapted. It helped a lot. I think DTE is a big support here.
Okay. What was the ENPI used for the ISO 50001?
The ENPI used, we were trying many different ENPIs before, but at one point we decided, how can we compare our facility to our sister facilities in Europe or even in North America? We all have different products, so it's tough to compare. So we decided to say we take the energy, which is the kWh, we converted the natural gas in kWh, we used the kWh from the electrical usage, and we divide it by hours worked. So if the facility is busy and if we produce more of our product, the hours work goes up and the kWh too. And if the ratio overall goes down, you're more efficient. The same as our colleagues from Germany do. So we are able in truck powertrain to compare our ENPIs, and we can get tracked by the CEO.
Okay. What was the significant energy use in your facility?
As we showed before, it is the boiler room,
Okay.
which is, and I probably can say, it's almost $1 million just for natural gas. It goes all through the boiler room, and it's just for heating. And probably also the E4 lab. I mean, I don't have now the exact number in my head, but we spend a ton of money for diesel, and 73% goes just to the E4 lab, just for durability tests. But it's
Okay.
research and development, so you have to be very careful how you react there.
Right. All right. Next question is, were the plant operators supportive with the energy management program, and was there any resistance?
At the very beginning, there was resistance, definitely. I mean, I remember the time when I just started, the plant manager said, okay, show me how you saved. Go on. So after a month, he said, so why don't you put solar panels on the roof? Why don't you do that? Why don't you do here? And I was like, okay, he kind of stressed, no? So I couldn't really use my approach for things. So definitely, they just started to believe in us when we started to earn money, let's say. When we had the ISO 50001 implemented, when we started with the SEP to show them, hey, we saved $37 million, they opened all the doors.
Okay.
I think also one of the things that really helped out when it comes to the floor operators is the LED lights. There's a big difference when you're going into work with those high pressure sodium and you got that orange glow to it. When you turn around and say, hey, we're going to do an energy efficiency project here, and I'm going to give you white light, and you're not going to come out of work thinking that you've been stuck in a building all day. They come out thinking that they've been outside the entire day. So they really see the immediate, it does impact them. At the end of the day, the bottom line plus, your work conditions have a lot to do with energy efficiency.
Good, good. That's interesting. All right. Was there ever a time that management wanted to stop SEP at Detroit Diesel or other places, and what happens to the stranded costs? You just save money on the efficiency, but just aren't tracking it?
Well, I think the facility was always doing energy management. I mean, the whole part of your facilities group is pretty much try to do as best you can. And the management here was extremely supportive. They had seen in other facilities how it does work. So at first it may have been, oh, well, let's see, how this goes. But once you start showing changes and the plant manager is now looking at, the final budget, and he just realizes, like, wow, why is there so much money left in the utility budget?
Yeah.
So
I think the other thing is, that $37 million doesn't even account for the last year.
Exactly.
You saved 7% more, right?
Yeah, we tacked on another $3.7 million this past year. And I can tell him all he wants. However, when he looks at his checkbook, he wonders why there's a lot more money left over that hasn't been spent, which went into general funds. So right then and there, he was extremely supportive. It has worked. And I think it also draws in the fact is pull from outside sources. If you are the first one in your company to start this, show, the Department of Energy has plenty of examples to show how it is successful.
Okay. Next question. It looks like the room where you have the awards and hold meetings is on the factory floor. Is that right?
Absolutely. The green corner is in a main aisle that everybody, from going to your workstation to pulling parts around, is in a very prominent location and is lit with LED lights. We invested a lot for aesthetic purposes for it to look good. that we are getting things accomplished, and people, no matter, it is very visible and reinforces the fact that energy and environmental do very much matter to Daimler in the facility. It's almost a subconscious type thing that it is. And we hold management meetings out there, so the hourlies and professional employees that are here do see the plant manager out there, and it is a core value, and it reinforces it subconsciously.
Great. So the next question you kind of answered, but maybe just expand on a little bit. How did you communicate the energy efficiency with employees? You talked about the shop floor. Is there anything else you have?
Yeah, I mean, we don't use the shop floors and the green corner for that. You can go there anytime you want and read about what we are currently doing. But we also have a good to know article. It goes out once a month. We even just had a special edition just about energy efficiency, which was the idea from the plant manager. He said, what about if we do a good to know article? We call it desktop alerts. We send out alerts to each computer here on site with some notes and information regarding the energy efficiency. We have an online database who everybody can access that online, and we have several TV monitors here on site, and we use those TV monitors also to go through PowerPoint presentation, including a lot of energy stuff and information regarding that. We have even an idea engine here on site, so for such very good ideas, you get rewarded, financially rewarded, and you can be part of it. And we also reward with an on-site parking. You can park right next to the plant manager. If you have a good project, an energy efficient project, an environmental good project, you get to park 2 weeks next to the plant manager. What's actually pretty neat.
No badging in either.
All right. Here's one. Awards you received were great. Recognition, perhaps something you didn't expect. But were there other things, benefit that this initiative achieved that you did not expect?
I didn't expect that all the people on floor would actually support us so much, because after they really saw, as Chris mentioned, with the LED and with all this recognition and awards, and this all is for Detroit Diesel. It's not for the energy team. It's not for the facility team or for the plant manager. That's for Detroit Diesel. This makes us look good, and everybody's proud of it. So you can see that the people really react on it, and people stop us on the floor with ideas and say, hey, I got an idea, I got a pump over there and I would like to change it, what do you think about it? So yeah, this surprised me a lot, and this is again part of the cultural change here on site.
And it also reinforces the fact is that this facility will stay. You know, the jobs will stay in Detroit. The more efficient we are about making engines, the cheaper that we can do it for, and employment for our families will continue to stay within the area. And that's a message that everybody can take home.
That's a big one. Okay. You already achieved 32.4% savings. Where can you make further improvement in this facility? Do you have a next target for this facility?
We have of course we have a 5 and a 10-year plan for that, and of course the low-hanging fruits, they are long time gone. No chance. So to make huge improvements, it would be what Chris said. We work on a steam reduction to shut off the steam in the summertime. But the best improvement would be like if we get a few $1 million and we convert it to hot water. I think this would be a huge thing. But now we are talking about a lot of money. And even with SEP, it will be a tough one to get that amount of money. So we are doing little steps to get close to it. And at one point, we'll replace maybe the steam boiler with a hybrid boiler, steam and hot water, and try to transition slowly to the next big project. That's the approach.
Yeah, right now we're currently going to be trying to get heat recovery is the next kind of topic that we have on the plate for the next couple of years.
Mm-hmm. So that's a good question I'll ask. I think we're out of questions on the chat, but keep your questions coming in if you have any. So I think when I visited you, we talked about payback, and I think the SEP process led to a change in thinking in the management in what the acceptable payback would be? Can you talk about that a little bit?
I mean, I mentioned that our corporate payback is 2 years, right? And especially with the low-hanging fruits is 2 years. But we all know that LED lights don't have a payback of 2 years. We're looking at paybacks of 6, 7, 8, or 9.
Or heat recovery, for that matter.
And heat recovery even more. So I think they would probably accept a payback of 4 to 5 years right now, but it depends about the amount. I mean, if we are looking at a boiler or something, or heat recovery, which costs like $5 or $6 or $7 million, there's still an economical impact. If we're looking at 20, 30, 40 grand, you could get that very easily now with that standing, even with a 4 or 5 year payback time.
Yeah, we very much lucked out here that our top management is able to, its long-term goals versus short-term goals. And the fact is that, you know, as our plant manager progresses up through the ranks, that his time at Detroit, it will help him in the future when he goes to the next level, that Detroit will continue to be a energy efficient and increase the bottom line. And that is absolutely invaluable that we have executive management here that does understand long-term goals.
Mm-hmm. Fantastic. All right, got another one. What is the frequency of energy updates or meeting? Sorry, it's kind of hard to read these questions.
I think I have an idea what the question is about. We have a weekly meeting on our Detroit Conserves group. This is a group of supervisors in the technical services, especially also security and R&D, where we talk about, do some brainstorming, talk about actual projects, little projects. We have also an interdisciplinary circle, which meets every 3 to 4 months. And there are actually, from each department, there's one representative there, and we update them and we take new ideas from there. And then we have a monthly meeting with the management, with all the directors and the plant manager, where we talk about the KPI, the tracking, and the measures.
Yeah, okay. All right. Let's see if I got all the questions.
Okay.
Are you extending the energy savings performance into your supply chain companies?
We are pushing in our contract management portals. We are asking our suppliers to, just like we do for environmental, to go ahead and talk about energy. We push them extreme as much as possible to develop energy management systems, not solely based on the fact is that it's good for the environment, but the fact is it saves money. Mm-hmm. The more profit they make, the streamlined the process can be. So we haven't said you shall, but we are showing the benefits that are happening at Detroit Diesel, and we recommend that they do the exact same.
Fantastic. Let's see, I think I had one more here. How would you design a new facility differently with this experience?
Oh, I mean, I would love to design a new facility like a greenfield, and I think I would need too much money for that. But I would try to use a lot of renewable energy, definitely. I would try to not use steam. I would try to go from the very beginning with the LED, and I would try to use like a white ceiling paint and clean floors, because then you show everything is nice, everything is efficient, and people like and love to work there. That's how it's supposed to be, but all that is extremely expensive. If I could use a greenfield, I would use like heat recovery, everything what's possible. I've never worked in a greenfield, and this would be a dream to do something like that. Yeah,
mm-hmm.
Pretty tough.
Okay. Well, we're up on the hour here of 3 o'clock. Really good questions by the audience. Thank you. And for Carlo and Chris, thank you very much. Randy, thank you. And
welcome. Thank you.
Yes. So we're going to end the webinar, and I appreciate this great case study you've given us today.
Thank you.
This concludes our webinar. Thank you.
Thank you.
Bye-bye.